Titrations are at their heart a mathematical tool. So we're going to be doing a lot of problems like this where we determine the concentration of a solution of acid, and you'll be given, so not always acid, sometimes base, but you'll be finding the concentration of a solution, and you'll use a known in order to do that. So we're first going to draw the titration curve, okay? So, and this is all, what the titration curve would look like. This side's going to be pH, and this side's going to be, and this time I'm taking NaOH and I'm adding it into the HCl, okay? So initially, I'm going to be in acid, which means my pH is going to be very low. So I'm going to be adding base to that. So the x-axis is going to be the volume of base or volume of NaOH. Okay, and my units are going to be milliliters here. And I'm going to start out low and I'm going to go up high. Okay, here's my equivalence point. Okay. And because this is a strong acid, strong base combination, the equivalence point is going to be at pH 7. Okay? And I'm also given that the equivalence point comes at 20 milliliters of NaOH. All right, so we're trying to find the concentration of HCl. So that's really what we're looking for. And I know that that's going to be moles HCl per liter solution. Okay. Now, one thing that people get mixed up about is I am trying to find the concentration of just this solution, this 20 milliliters, or sorry, this 10 milliliters of HCl. I'm not trying to find the concentration of HCl once I've added everything. So I know that this is going to be over 10.00 milliliters of HCl. Okay? So the thing that I have to find is the number of moles of HCl I have. All right? Well, I need to first write my equation. So that's HCl plus NaOH yields NaCl plus H2O. Okay? Everything's 1-to-1, so this should be pretty straightforward. So my question mark moles HCl is going to be 20.00 milliliters NaOH times 1 liter over 10 to the 3rd milliliters times 5.0 times 10 to the minus 3 moles NaOH per liter solution. Okay, and then I'm just going to take my moles of NaOH to moles of HCl. So 1 mole NaOH to 1 mole HCl. And this is just molar ratio, which I got from the balanced chemical equation. So this is 1.000 times 10 to the minus 4 moles HCl. Okay, and I can take this value and I can plug it in right up here. Okay, I need to convert this milliliters to liters. And then I get my answer, which is 1.000 times 10 to the minus 2 molar HCl. And that's my answer. So even though these seem like pretty long problems, okay, they get kind of steppy, this is a very simple procedure, and you've done most of these types of calculations before. You've used molarity to convert from volume of a solution to moles of a solution. And you've used mole ratio to convert from one thing to another thing. It's just kind of putting everything together.